Hello everybody and welcome back, and now let us continue on fixing our reverse shell and server code. So we will start off with server. As I said, we will fix this code a little bit, add some functions here and there, and we will also add two functions, one for sending data and one for receiving data, which will allow us to actually send and receive as much data as we want. As we can see right here, the result equals target receive of 1024 bytes is limited to this. If the target output or answer is bigger than this, it might actually make our program crash. So we want to fix that first of all. For example, for any bigger command such as netstat, this will not fit into 1024 bytes. So let's first start off by actually putting our server function. So we will put this part of the code in our server function. So we can actually make it a little bit prettier. So let's copy this. Copy. Let's go all the way down, since we will specify it down here, and paste the same code. Then right now what we can do is we can actually delete this. So we can delete all of this. Now I know this isn't a pretty code, but trust me, it doesn't really matter as long as it works and as long as it doesn't break. So first thing we want to do is, first of all, separate it from the while loop. Then what we want to do right now is actually make a function. So def server, and then we will put all of this in that function. So creating a socket, then by setting socket options, then binding the socket, all of that should be in the same function. We can also print listening for incoming connections, and then we can accept the connection as well, and print target connected. So you will notice that we also use this s variable right here in the other commands as well, or pardon me, not the s variable, we use the target variable in the other commands. So what we want to do is make those variables actually global, so we can use it in any other function we make, or in our while loop as well. If you just specify the variable inside the function, it will only be used in that function and won't be recognized outside of the code of that function. So we need to make those variables to be global. So global s, global IP, since we use IP right here, which is outside of the function, and global target. So target is also something that we use in order to send and receive the output of the command. And right now this should be good for the target, for the server function. If we need to add anything else afterwards, we will add it. Now right now you will notice something wrong, which is how can we actually execute this. So we actually have to call the function in order to execute it. So we will do that with server, and then the open parentheses and close parentheses, which will call this function, which will execute this function, and which will go down to execute the code. But the next code, as you can see right here, is s.close, or basically as soon as this program starts, it will go into the while true loop first before doing any of this. So we want to make a function for the while true loop as well. We will call that function shell. So first of all, let's go upwards and let's define that function to be shell. We'll just call it simple, since shell is something that we use to execute the commands, and we tab all of this into our shell functions. Tab it all just once, so it looks good. And this should be it. Now you might notice that we didn't call the shell command, so we have to call it down there. We have to call it after the server command, so we can't actually execute the commands before the target connects back to us. So the server function has to be called first, and then the shell function has to be called right after the server function. So our shell function will run indefinitely until we as an attacker enter the command Q, which will terminate the connection and which will continue outside of the while loop, and will go to the next execution of s.close, which will close the program and the connection. So this should be it. I believe everything is set good. Now you might be asking, why doesn't this execute this? Well, basically once you have a code in a function, the machine doesn't read the code, or the Python doesn't read this code in a function until the function gets called. So we have to call it in order to execute this code right here. So what we want to add as well is two functions that will actually make us able to send and receive as much data as we want. So we will code that up, so make space, and let's call that reliable send. So reliable underscore send, and we want to input a data to that function. So reliable send will be our command, which we will input in this function, and then we have to add another library which we will use in order to dump that data and make it send as much bytes as it can. So import JSON is the name of the library that we will use. So just type upwards import JSON, and then in our function what you want to do is JSON underscore data, we'll call it like that, equals JSON dot dumps, which is a function, and then we want to use data in that function. So JSON dot dumps, and then we want to specify data inside the brackets. Then we want to type our regular socket send function, which is target dot send, and we want to send the JSON data underscore data, and this will be our reliable send, which means we can send as much as we want. So let us actually switch all of our target.send with the reliable send. So we can see right here we have the one and only target.send, so we will just delete that and type here reliable underscore send, and then we send the command. So then our command will get put in this function right here, and then the JSON data will take the value of JSON.dumps of our command. Then we will send the JSON data to the target. So right now what we want to do is also code a function that will perform a reliable receive. Now the reason it's called reliable is because it will actually receive as much bytes as the target sends. So let us code that as well. Define, which is the short for function, reliable underscore receive. Now you can call these functions anything you want. I will just call it like this. And right now what we want to do is actually perform a little bit of a bigger code than for the reliable send. In the reliable receive, we do not need to specify anything between the brackets, since we are the one that are receiving the results of our command. So we want to specify a local variable called JSON data equals and then the empty string, and we want to run a while true loop in order to actually add the bytes per byte, so 1024 bytes to another 1024 bytes until we run out of bytes. Well, it sounds maybe sounds problematic, but it really isn't. So just type here a while true loop, which is an infinite loop. And we want to perform something that we used before, which is the try and except rule. So it will try something, except when it receives an error, and we will use that error in order to continue. So let's try to code this. So try, this should work. Try JSON underscore data equals JSON underscore data plus target dot receive, and we want to receive here 1024 bytes as usual. And then after that we want to return the function JSON loads of our JSON data. And then if that is it, if the JSON data is basically lower than 1024 bytes, it will return it, except it will give us a value error. Now I already checked this, so I know that the name of the error will be value error, so I just type it right here, except value error, 2 dots, and then continue. Why do we specify here continue? Well, basically if we get a value error, it means that the data that the target sent was larger than 1024 bytes, which means we need to go back to the while true loop, and then it will perform the receiving on 1024 bytes once again, and it will add it to our variable JSON data, which also has the previous 1024 bytes. And it will do that as long as there is some bytes left to receive, and as soon as the bytes are no longer left to receive, it will just quit right here, and it will send us back all of the bytes that the target sent. So these are two functions used to send and receive as much data as we want. But right now, since we coded the reliable receive, we want to change this. So result equals, we delete 1024 bytes, since in our function we did not specify anything in the brackets, and result equals reliable receive. So we will get the result right here, and we will print the result. So this should be good, all should be good for now. We have the command equals q is break, else result equals receive reliable receive, and then print the result. Then we go back to the while true loop, and then we get prompted for the same command, which we send with our reliable send command. Good. Let's see down here. We coded a function server, we called the shell function in while true loop, and we also called reliable receive and reliable send function, which we use in our shell loop. Good. So this should be, I believe, it for the server. So let's close it. Now let's, before we close it, actually call two functions, since we will use same functions in our client server, in our client code, which is our reverse shell. So we copy this, we close this, and then we nano the reverse shell.py. Here, let us just paste these two functions right away, and we have to actually change a few things in these functions, since we do not have something called target in our client code. We have to change that into actually sock. So as we can see right here, in our client code we actually send and receive data with sock.receive and sock.send. So we have to change that right here as well. So it's not target.send, it is sock.send. So let's delete this, sock.send, and we send the JSON data, and here we have to type here sock.receive, since that is what we specified in our client code. Good, so we have the functions ready. All we have to do right now is actually use them in our while true loop. So sock.receive we do not longer need that, we only need reliable.receive. And we delete the 1024 bytes. Then right here, once we send the result, we do not need to sock.send, we can use reliable_send, and we send the result. But right here, let's also run a simple function so this code looks a little bit prettier. What we want to do is, let's actually create down here. What we want to do is also on our while true loop create a shell function. So while true will be put in a shell function, define shell, we will call it same as in our server code, and all we have to do is just tab all of our code. So tab this, tab this, tab this, tab, and just do same with all of these code. Now that we have a shell function, we have to call it, but before we call it, we actually have to perform the connection. So let's actually copy this upper code below all of these functions right here. So copy this, then we can delete this, and we'll paste it at the end of our code. So it actually goes through all of our functions before executing that code. And we paste it right here. So we paste the same code as it was upper. So let's see if this will work. Sock equals socket.socket, socket.afinet. Okay, we connect, we print connection established to server, and then we can run our shell from here. And then we enter the while true loop, which makes us execute the commands on target PC. So we have the reliable send and reliable receive function, and right now I believe we should be good to go. But before we actually save this program and run it, let's run a simple try and accept rule for executing the command on target server or on target machine. So right here, this is the part of the code where we actually execute the command that we get from the server and send the result back to the server. Here we want to run a simple try and accept rule for the commands that can be run. So try, we want to try to execute the command. We want to try to do all of this and then send the command back to us, and then accept So for every time a command can be executed for some reason on target machine, we want to make and try and accept rule so our code doesn't break. So for every command that can be run, we want to reliable send or send to our target machine, reliable underscore send, open brackets, let's make it like this, can't execute that command. We can do it like this, or we can put this string in a variable and then prompt it to the reliable send. But we can also do it simply like this, just by sending a string to our reliable send function. It is the same as if we actually took this string, put it in a variable, and then printed and then put the variable between these brackets. So this should work, if you ask me. For now on, let us just save this right here. Exit, and then let's first of all check out the server before we run it. We have the reliable send, the shell function, the server function, okay. And let's run the server. Right now we are listening for the incoming connections, so let's open another window, view, zoom in. Oops. Let's put this so we can see both of the windows. Let's go to the Python reverse, and then we run, or let's clear the screen first, and then we run the reverse shell.py. So the connection established well right now, so we know that on our server the connection or the server function was executed, and we went into our shell function which prompted us for executing command. So let's type here ls, and something right here doesn't work, so let's see what. Here we can have, oh yes, in our reverse shell, of course, we didn't import the JSON library, so let's close this. We do not need this terminal. In order for us to use these functions right here, as we did in the server code, we need to import the JSON library, so we can use these functions, json.dumps, json.load, loads right here. We need to have that library so we can use those functions, otherwise that our code will not recognize them. So import JSON, then let's save this once again, close this, let's open another terminal, enlarge this right here, view, zoom in, make this a little bit smaller, go to the Python and reverse, run our server once again, run our reverse shell, and then execute ls command. So we can see we successfully executed our reliable send and reliable receive commands. So everything works perfectly for now. So let's see who am I, and what if I type here ansted.ntp, for example. We get everything right here, clear. It clears the screen, since we actually cleared the screen of our terminal. Who am I, pwd, I don't know, we can try ifconfig. So we get output of all of these commands back to us. Also, if we type here enter, as you can see right now, it doesn't actually hang on the code, and we can still execute the command. So if I type who am I, we can still get the result of the commands. That's because we implemented that try and accept rule on executing the command. It tried executing nothing as a command, and it didn't work, so it actually skipped right to it. So we can try executing something that doesn't exist, or let me just see, so we can get prompted can't execute that command. Let's see dir. Okay, so dir works as well right here. Well, I believe we will get to that sometimes. It doesn't really matter. What matters is that our code now works. We can execute all of the commands. We can just print out PS to list running processes. We can print working directory. We can do anything we want. We can create directory, so mkdir test, and if we type here ls once again, we can see there is another directory right now called test in our file folder. So that's good to know. Now let's see if the Q option works as well. So we type here Q, and we can see both programs close without any error, which is good. And right now, if I type here ls, you can see we still have the test directory. So I will just remove it since we don't really need it. And right now we have a working reverse shell and server.py. which can be used to execute system commands on target. But there are still some things that don't work here, such as changing our directory. For example, if I try to change my directory, I won't be able to. We will see how we can actually fix that as well, and then we will start adding some more functions and some more available things for our reverse shell. So that would be about it for this video. I hope you enjoyed it, and I hope I see you in the next one. Bye.